Today we're going to learn about permutations and combinations, but first we're going to start out with a problem. So why don't you pause your video and you can read the paragraph and try to come up with a list or try to answer the problem. Pause now. Okay, now that you've resumed the video, I'm going to go through one way that you could answer this problem. So we have three cities to go to: Stockton, Boise, and Phoenix. I'm just going to use S, B, and F, or P, sorry. So imagine we could go to Stockton, then Boise, then Phoenix. We could also go to Stockton, then Phoenix, then Boise. We could do Boise, Stockton, Phoenix, and then we could do Boise, Phoenix, Stockton. And finally we could do Phoenix, Stockton, Boise, and Phoenix, Boise, Stockton. So here's one way to solve this problem, is you can just make an organized list. As you can see, I just started with Stockton, and I did both things that could happen if you went to Stockton first. Then I went to Boise and went through both things that could happen if you went to Boise first, and then Phoenix, and so on. Now imagine if this trip that you were going on had more cities. So how would this list get larger if you had 4 cities, or 5 cities, or 6 cities? Okay, you can see with this list of just 3 cities, it's already fairly large. I mean, you got 6 different trips you could make. You would find that if there were 4 cities, there's actually, let's see, 24 different trips you could make. So that would be pretty tedious to make a list that long. And so that's why we're going to learn about permutation. So an arrangement of a group of items in a particular order is called a permutation. In the case of the problem we just worked on, the items that we're ordering are cities, and each of these lines is a permutation. So we have 1, 2, 3, 4, 5, 6 permutations of the different trips we could go on. So there's a real easy way to do it. Let me move this out of the way for a moment. And there's a notation we can learn, and it is, well, P for permutation. You put the number of things that you're ordering. So in the case of our first cities problem with 3 cities, we say we're going to order 3 cities, and we're going to order them all, and we'll get to the second number later. 3P3 means that you're going to multiply 3 times 2 times 1. The times 1 doesn't really do much, obviously, but 3 times 2 is 6, times 1 is 6, and as you can see, we had 6 in our list. Now if we had 4 cities, it would be 4P4. So if we were going to 4 different cities, we would solve that by doing 4 times 3 times 2 times 1, and like I said, that's going to equal 24. And with 5 cities, we could do 5P5, and we could say 5 times 4 times 3 times 2 times 1, and that would equal 120. So that's pretty crazy that with only 5 cities to go to on a business trip, there's 120 different ways you could go to those 5 cities. It really gets big fast. Now, you can do permutations where you don't go to all 5 cities. Let's say on this business trip, you would like to be able to go to 10 cities, but you just don't have time. So you're going to choose 3 of them. And so how would that work? So let's make a little line here. So if you had 10 cities that you would have liked to go to, but you can only make 3 of them, then you have 10 cities to choose from, but you're only going to 3. And so in this case, the first choice you have, there's 10 possibilities. After you go to that city, there's 9 possibilities. And after you go to that one, there's 8 more possibilities. So that would just be 10 times 9 times 8. And so you can see what this second number is doing. That's the number of things you're choosing to order. So the first number is, the 10 in this case, is how many things you're choosing from total. And then the second number is how many of those things you're going to order, or how many choices you're going to make out of those. So in this case, 10 times 9 times 8, I believe, is 720. If you had 5 cities to choose from, and you only have time to go to 4 of them, that's 5p4. That means the first city you have 5 choices, the second city you have 4, the third city you have 3, and the fourth city you have 2 choices because there's only 2 left. So the second number, when you're dealing with the permutation, is just how many multiplications you have. And notice each of these step down by 1, because that's one less thing you have to put in the order each time. So 5 times 4 times 3 times 2 is 20, 60, 120. Or if you had 7 cities to choose from, and you were going to choose 3 of them, it would be 7 times 6 times 5, and that would be 210, I think. Okay, so that's the permutation notation, and it's a quick and easy way to figure out how many different arrangements there are of a certain number of items. Okay, one of the ways you might use this is if you were a musician or a music producer and you had 8 great songs that you really loved, but you wanted to make sure that when the listener was listening to them, they got it in the right order and it really showed the flow of the album. Okay, so if you had 8 songs and you want to order them just right, I mean, how many different possibilities are there to begin with, right? So that's 8. You're going to order all of them because you're going to put them all on the album. So 8p8, and that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is going to be quite a large number. Imagine, just 8 songs. There's so many different ways you can order them on an album. I almost don't even want to do the math. I'll let you do the math, figure that out on a calculator or whatever. But that's how you would do that. Okay, now let's change the story a little bit. So let's say you're still a musician or a music producer, and you have more than 8 songs. But you only want to choose 8 songs to put on the album, but you have 20 songs or 30 songs or 15 songs, and you'll just save the rest for another album or another album after that. So let's say you have currently 12 songs. All right, so we got 12 songs. You're only going to choose 8 of them for the album. Now, before we even get to the ordering aspect, which is the permutation we were talking about, we just want to know how many possible ways you could choose 8 songs without the order, right? So let's get back to a simpler problem here. If we said, getting back to the cities one, let's say you had 3 cities that you would like to go to, but you only have time to choose 2 of them. Okay, how many different combinations of the 2 could you go to? Okay, well, you could choose to go to Stockton and Boise. You could choose to go to Stockton and Phoenix. You could choose to go to Boise and Phoenix. Okay, now if you said Boise and Stockton, well, in just the fact that you're choosing to go to these 2, you've already said that you're going to Boise and Stockton, so you don't need to say, or you said Stockton and Boise, so you don't need to say Boise and Stockton. Okay, so if you're going to figure out the order later, and you just want to know what cities are the most important that you're going to choose from, in this case, there's only 3 possibilities. Okay, Stockton, Boise, Stockton, Phoenix, or Boise, Phoenix. And so notice there's a lot less combinations, okay, because these care less about the order, or not at all about the order, in fact. So getting back to the choosing songs, in this case, we're going to choose 12 songs. From 12 songs, we're just going to take 8 of them. Okay, this is what we're going to do to solve this is called a combination. And so you're going to a combination is a group of items chosen from within a group of items. So we're going to start with 12 songs, and we're going to figure out how many combinations of 8 songs we can get out of those. Okay, now this is a little trickier. What you do for a combination is you start with a permutation, 12p8, and then you divide by a permutation 8p8. And don't worry, we're going to do plenty more examples of this tomorrow in class, but I'll try to get some examples done on here as well. So 12p8, so the first part of the combination, as you can see, it's a division problem. The first part is just replacing the c with the p right here, so that's 12 times 11 times 10 times 9. That's, oh, we're doing 8, so 1, 2, 3, 4, 5, 6, 7, 8. So 8 multiplications going down. So 1, 2, 3, 4, 5, 6, 7, 8. And now on the bottom, we do 8p8, so that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now all those times I've begged you and pleaded with you to reduce before you multiply when you're dealing with fractions, here's a really important reason why. Imagine multiplying 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 and getting this enormous number, and then dividing by this pretty big number on the bottom, and then having to reduce. That would just be miserable. Luckily, if we reduce first, it'll be much easier. So the 8s go away, the 7s go away, 6s go away, 5s go away. This 4 and this 12 can reduce to 3. This 3 and the 9 can reduce to 3. This 2 and 10 can reduce to 5. So that's a much more manageable number. So we have 11 times 5 times 3 times 3. So what is that? 495 or something? That's a guess. Let me recheck that. Okay, so we got 55 times 9. 55 times 10 would be 550. Take away 55. Alright, I'm confident. So 495 different groups of songs can be chosen from 12 songs if you're choosing 8 songs. So you could choose that in 495 different ways. Okay. Then once you get those 8 songs, then you can figure out this however many ways to order those 8 songs. Okay. So let's try some combinations really quick before we finish this video. So let me just put up a few examples so you get the idea, and then in class we can practice some more application. So if I write 5C3, that means we're choosing 3 things from a group of 5. We would say 5P3 on top and 3P3 on the bottom, and that would look like 5 times 4 times 3 over 3 times 2 times 1. Again, we want to do our reduction first, and we realize that our answer is 10. Okay, let's try another. Let's say 8C, about 2. 8C2 would be 8P2 over 2P2. Now that means you're choosing 2 items from a group of 8. Like if you had 8 students that wanted to be the class representatives and you're choosing 2 of them, how many different groups of 2 could you get? So we got 8 times 7 on top and then 2 times 1 on the bottom. Again, we want to reduce first to make that as easy as possible. And there's 28 different ways you can get 2 class representatives from a group of 8 students who want to be the rep. Okay, let's try one more and I think we could be done. Let's say 5C4. Okay, 5C4, we have 5P4 over 4P4. And so we go 5 times 4 times 3 times 2 over 4 times 3 times 2 times 1. Do some reduction, and we end up with 5 different possibilities. So when we're choosing a group of 4 people from a group of 5, the reason there's 5 possibilities is because each time one person is left out, right? And so of the 5 people, each time one is left out, so there's 5 different choices. Alright, that should be it for the video. Thanks for watching.